Welcome, dear friend, to Luminous Uplift, a quiet place where science becomes a lullaby and the wonders of the universe gently carry you toward rest. If today has been long, if your shoulders still carry the weight of hours that stretched and pulled at you, then this is your invitation to soften. Breathe slowly. Let your eyes grow a little heavier. You are safe here, and there is nowhere else you need to be. Here at Luminous Uplift, we tell stories that lift the spirit without rushing it. Stories woven from curiosity and calm, where knowledge arrives not with noise, but with the quiet grace of starlight traveling across an ancient sky. Tonight, we journey together through one of the most breathtaking stories the cosmos has ever written, the life of a star. We will drift through vast velvet clouds of gas and dust, where stars are born in silence and slow luminous wonder. We will follow their long, glowing lives as they burn with warmth and purpose across millions of years, and we will witness, gently and tenderly, the peaceful ways they fade, collapse, or bloom into something beautifully new. This is a channel for dreamers, for the quietly curious, for souls who find comfort in knowing how extraordinary and vast and deeply connected everything truly is. If that speaks to you, perhaps let a like or a quiet subscription be your way of staying close to this little corner of the cosmos. Now, let us begin our journey into the luminous life of a star. Close your eyes for a moment and let the world around you grow very, very quiet. Let the sounds of the day dissolve like breath on a cold morning, like ripples fading across still water. There is nothing you need to hold on to right now, nothing you need to remember or plan or carry. There is only this moment, and beyond this moment, there is the oldest darkness you could ever imagine, stretching outward in every direction without end, filled not with emptiness, as you might first suppose, but with something far more tender and far more strange, filled with clouds, immense, slow-drifting clouds of gas and dust so vast that if you were a beam of light and you tried to cross from one edge to the other, it would take you not seconds, not hours, but years, decades, sometimes centuries, just to pass through. These are the nebulae, the great soft architectures of the universe, and they have been waiting here, patient and quiet, for longer than our small human minds can easily hold. Picture them as you drift towards sleep. Picture them not as the cold or frightening things that the word space sometimes conjures, but as something more like a nursery, a room where the universe keeps its unborn light. The nebulae are made mostly of hydrogen, the simplest and oldest element there is, born in the first blazing moments after the universe began. Hydrogen is humble in the way that seeds are humble, in the way that a single note of music is humble before it becomes a song. Mixed in with this hydrogen is helium, the second element, light as laughter, and then traces of other things, carbon, oxygen, nitrogen, and the finest imaginable grains of dust, smaller than anything you could see, smaller than anything you could feel between your fingertips, yet present in their millions and billions, drifting slowly through the dark like snow falling so gently, it barely moves at all. And so the nebulae hang there enormous and soft, lit in some places by the light of nearby stars that paint them in colors we could never manufacture. Colors that look like rose and amber and the particular deep blue of sky just before night fully arrives. They glow with a quietude that is almost hard to believe given their scale. If you could step outside every city, outside every building, outside every electric light in the world, and look up at the right patch of sky, you might even catch a glimpse of one with your own eyes. The Orion Nebula sits just below the three bright stars of Orion's belt, a faint smudge of light that has been there for every human eye that has ever looked upward in wonder. Ancient shepherds saw it. Ancient sailors used it to navigate. Children in every era of human history have looked at that soft glow and wondered what it was. And what it is, what it truly is something almost impossible to describe in ordinary language, because it is nothing less than a place where stars are being born right now, at this very moment. Even as you breathe in and breathe out, and let your body grow heavier against the softness beneath you. Within the Orion Nebula alone, there are hundreds of stars in various stages of coming into being. Hundreds of suns, each one at a different point in the long, slow, extraordinary process of being born. Some are still mostly cloud, still mostly suggestion and potential. Some have gathered themselves into something denser, something with more sense of self. Some are nearly ready to ignite, to burst into that ancient light that will pour outward across billions of miles of space for billions of years. All of them are there right now, nested inside that soft smudge of light that you could find in the winter sky, with nothing more than your own patient eyes. There is something deeply comforting in that, something that makes the distance between us and the stars feel perhaps a little less cold, a little less impossible to cross with the imagination. But let us slow down even further, because the story of how a star is born is not a fast story. It is one of the slowest stories the universe knows how to tell. And slow stories are exactly the right kind of stories for this quiet hour. The birth of a star begins not with a bang, not with any sudden drama, but with the gentlest of inclinations. Within the soft body of a nebula, within that vast and wandering cloud, there are places where the gas and dust are slightly thicker than elsewhere. Just slightly, a little denser here than there. The way that fog sometimes gathers a little more heavily over a lake in the early morning. The way a river current will run a little deeper in certain places without any visible reason. These small differences in density are all that is needed to begin one of the most extraordinary processes in the known universe. Gravity, that patient and invisible force, begins to take an interest. Gravity is not in a hurry. Gravity has never been in a hurry. It simply notices that there is a little more matter gathered in one place than another, and it begins very slowly, very gently, to draw things together. The denser region begins to pull at the gas and dust around it, and because more gas and dust are gathering, the region grows denser still, which means it pulls a little harder, which means more gas and dust arrive, which means it grows denser still. It is a slow conversation, a slow accumulation, a kind of cosmic patience that is almost meditative in its quality. Over millions of years, and we must not rush past that phrase, over millions of years, this region of the nebula collapses inward under its own growing gravity. Think about what millions of years feels like. Our entire recorded human history, everything we have ever written down, every war and discovery and love story and invention, stretches back only about 5,000 or 6,000 years. The pyramids of Egypt are roughly 4,500 years old, and we already consider them ancient beyond easy imagining. Now multiply that by 1,000, and then keep going. The collapse of a stellar cloud into a protostar takes on the order of 100,000 years from the first meaningful gathering of material to the emergence of something we might recognize as the precursor of a star. 100,000 years of slow falling inward. 100,000 years of gathering and warming and tightening, like hands slowly folding together in the dark. As this cloud collapses, something remarkable begins to happen to it. The material falling inward begins to spin. This happens because of a principle called the conservation of angular momentum, which sounds technical, but which you already understand in your body intuitively. Think of a figure skater who begins to spin slowly with their arms stretched wide, and then draws their arms inward, pulling them close to their body, and suddenly spins much faster without any additional effort. The collapsing cloud does the same thing. Any tiny rotation that existed in the original cloud, even the most imperceptible drift, becomes amplified as the cloud pulls itself inward. It spins faster and faster as it shrinks, the way water spins faster as it approaches the drain. And this spinning shapes the cloud, flattening it, pulling material into a disk around a growing, thickening center. That center is where the most extraordinary thing of all is beginning to happen. As the gas and dust pour inward and pile upon themselves, as gravity continues to press and press and press, the material at the very heart of the collapsing cloud begins to heat up. This is because when you compress gas, you add energy to it, and energy is heat. You already know this in a small way. You know it in the warmth that rises from a fire as logs are added. You know it in the way a bicycle pump grows warm when you press it quickly. The same principle, enormously magnified, begins to work at the heart of this collapsed and spinning cloud. The temperature rises. What was cold beyond imagining begins to carry a warmth so new to the universe in that place that it feels almost like a first breath. This warming gathering center is beginning to become what we call a protostar, not yet a true star, not yet the blazing self-sustaining light engine that a mature star will one day be, but something coming into being, something on its way to light. It takes roughly 100,000 years for this collapsing cloud to reach a stage where we would recognize a protostar at its center, where we could look at this object with the right instruments and say, yes, something is here, something is gathering itself, something is learning how to be. 100,000 years is the infancy of a star. And just as every human being who has ever lived began as something very small and very tender and very full of potential, so too does every star in the sky begin in this way, as a warm and slowly brightening center within a collapsing cloud, surrounded by a disk of remaining gas and dust still pouring inward, still feeding the new and fragile brightness at the heart of things. The universe has been making stars this way for almost 14 billion years. Since not long after the very beginning of everything, these nebulae have been quietly doing this work. These vast, soft clouds of hydrogen and helium drifting through the dark, gathering, collapsing, warming, spinning, becoming. Every star you have ever seen in the night sky was born this way. The sun that warms your face in the morning was born this way, inside a nebula that no longer exists, in a time before the Earth itself had formed, in a time before there was anyone to watch or wonder, or tell the story. The sun was once a protostar, once a warm and brightening center within a collapsing cloud, once nothing more than potential and patience, and the slow, inexorable persuasion of gravity. And there is something about that continuity, that unbroken chain of becoming, that the universe has never once interrupted, that feels like a kind of reassurance, though it is very hard to put into words exactly why. Perhaps it is because we are made of the same stuff. The atoms in your body were forged inside stars, dispersed when those stars ended their long lives and gathered again into you. You are part of the same story. Your existence is downstream of the same slow collapse. The same patient warming, the same spinning and gathering and brightening that has been happening across the darkness since almost the very beginning. When you look up at a nebula or at the soft glow of the Orion Nebula on a winter night, you are not looking at something foreign or unreachable. You are looking at something that is, in the deepest possible sense, familiar, something that is part of the long story you yourself belong to. Let all of that settle now, softly, like dust in still air. Let the image of those great clouds drift through your mind, soft and enormous and patient, hanging in the dark between the stars, full of hydrogen and helium and the finest imaginable grains of dust, full of the slow beginnings of light. Let yourself feel for a moment the particular quality of that darkness. Not an empty darkness, not a cold or hostile darkness, but a darkness that is full of the most extraordinary kind of waiting. A darkness that is, in its own way, a kind of warmth, a kind of gestation, a kind of love that the universe extends to its unborn stars. And within one small part of that immense and gentle darkness, within the soft interior of a nebula that might look to the distant eye like nothing more than a faint smudge of cloud, a region of gas and dust that is ever so slightly denser than its neighbors, has begun to listen to the quiet call of gravity. It has begun, over the long and patient millennia, to turn inward, to gather, to spin a little faster as it falls, to press itself together with a slowness that makes all human timescales seem like the blink of an eye against a long, dark sky. And as it falls and turns and presses and gathers deep at its very center, where the density is greatest and the pressure is the most insistent, where all of that patient collapsing mass has been pressing inward for thousands upon thousands of years, something is beginning to change. Something is beginning to rise. Something as old as the universe itself in its nature, and yet as new as any birth in its particular expression. And so, within that slow and ancient darkness, the first trembling warmth began to gather at the heart of the cloud, pulling dust and memory together until something new and irreversible had already begun. Something that no force in the universe could quite convince to stop. Picture it, if you will, the way you might picture a dream you almost remember. There is a center to things now, a place where the pressure has grown so tremendous, so patient and so absolute, that even the empty spaces between atoms have been squeezed away into nothing. The gas that was once drifting and formless, scattered across distances too vast to hold in the mind all at once, has been falling inward for thousands upon thousands of years, each particle tugged by the gentle insistence of gravity, each molecule answering that ancient call with a slow and steady descent toward the middle of everything. And in that middle, in that innermost chamber of what will one day be called a star, something extraordinary is about to happen. Something that has happened billions of times before, across billions of galaxies, and yet never loses its quality of miracle. The temperature is rising. It has been rising for a long time now, climbing degree by degree the way the air in a room slowly warms when someone has been sleeping in it, when breath and body have been quietly at work. But the scale here is so far beyond anything a sleeping body could produce that the comparison almost makes you smile, almost makes you feel the smallness and the sweetness of human warmth in contrast with what is coming. Because what is coming is not the warmth of a blanket, or a hearth fire, or a summer afternoon. What is coming is something altogether more fundamental, more ancient, more woven into the fabric of what matter itself is allowed to do. 10 million degrees Celsius. Let the number rest in your mind for a moment without trying too hard to understand it, the way you might let a piece of music move through you without analyzing every note. 10 million degrees. At this temperature, something changes. Something gives way, or perhaps more accurately, something opens. The atomic nuclei that have been jostling and colliding and bouncing off one another in the dense, furious heart of this collapsing cloud are now moving so quickly, carrying so much energy in their tiny frames, that when they meet, they no longer simply glance away. The electromagnetic force that usually keeps protons from drawing too close, that invisible wall of like-charge repulsion that under normal circumstances sends particles spinning away from each other, is no longer sufficient to hold them apart. They are moving too fast. They are pressed too close. And in the infinitesimal space where two hydrogen nuclei finally come near enough, something older and stronger than electromagnetic repulsion reaches out and takes hold. The strong nuclear force, the deepest and most powerful of nature's fundamental interactions, and it draws them together. Fusion has begun. Two hydrogen nuclei, each one a single lonely proton, come together, and through a chain of events that unfolds with the quiet logic of inevitability, they begin the process of becoming something new. Through intermediate steps, through the brief existence of particles that wink into and out of being in fractions of a second, through the release of neutrinos so light and so ghostly they will pass through the entire body of the forming star, as if it were not there at all. Hydrogen is being transformed into helium. 4 hydrogen nuclei, 4 of those single protons, combine over the course of this process to form one nucleus of helium, and in that combining, something very important happens. The helium nucleus that results weighs ever so slightly less than the 4 hydrogen nuclei that went into making it. A tiny, almost imperceptible difference in mass. And yet, this is where the universe reveals something about itself that took humanity until the 20th century to understand. Something that a man named Albert Einstein encoded into perhaps the most famous equation ever written. E equals mc squared. Energy equals mass multiplied by the speed of light multiplied by itself again. And the speed of light is a number so vast, 300 million meters per second, that when you square it, you arrive at something almost incomprehensible. Which means that even the tiniest sliver of mass, when converted, releases an extraordinary torrent of energy. And so this small difference in mass between the hydrogen that went in and the helium that came out is not lost. Nothing is ever truly lost. It is transformed, liberated, set free into the interior of the forming star as pure and radiant energy. Light and heat and pressure blooming outward from the core in all directions, seeking escape the way water seeks lower ground, the way warmth always reaches toward the cold. And this is the moment that changes everything, because until now, the story of this cloud, this stellar nursery, this slowly collapsing nebula, has been entirely the story of falling inward. Gravity has been the only narrator, and gravity tells only one kind of story, a story of gathering and pressing and pulling everything toward the center. But now there is another voice in the telling. Now there is a pressure building from within, an outward push that rises to meet the inward pull that stands against the collapse and says quietly but with extraordinary certainty, "This far and no further." Physicists call this hydrostatic equilibrium, which is a phrase that sounds complicated but contains within it something almost poetic if you let it settle slowly. Hydrostatic, from words meaning fluid and standing still. Equilibrium, a balance, a poise, a resting place between opposing forces. the outward pressure generated by fusion energy pushing against the inward pressure of all that gathered gravity, and the two finding, after all this time, after all this falling and gathering and warming, a kind of peace with each other, a steadiness, a balance that can be maintained not for a day or a year or a human lifetime, but for billions of years of that same conversation between expansion and contraction, between the fire at the heart and the weight of the whole, balanced on the point of a needle that never quite tips. A stable star has been born, but it is not yet visible, not yet, because surrounding this newly ignited heart, this place where fusion has begun its long and patient work, there is still the cocoon, the dense envelope of gas and dust that has been gathering and falling and thickening throughout all the long years of the protostar's formation. The material that has not yet been swept inward to join the core, that lingers in a shroud around the newborn, the way fog lingers in a valley in the early hours before sunrise, before the day has decided to fully announce itself. The protostar has been hidden within this cocoon for thousands upon thousands of years, invisible to any observer who might have been watching from a distant world, detectable only in the infrared. In the gentle warmth, it radiates outward as a whisper rather than a shout. Astronomers who study these objects with instruments tuned to wavelengths of light beyond what human eyes can see have observed these hidden protostars, these embryonic suns wrapped in their dusty shells, these not yet stars waiting in their dark and private spaces. And there is something almost tender in the thought of them waiting there in the dark without knowing they are waiting, building toward the moment when they will no longer be able to contain what they have become. That moment arrives with the ignition of fusion, because the energy now streaming outward from the core is not merely warmth. It is radiation pressure, the literal pushing force of light and energy against matter, and it builds and builds until the cocoon that has been surrounding the protostar, that dense shell of gas and dust that has been its home and its hiding place and its cradle, begins to feel the force of it. The stellar wind, the outflow of energetic particles and radiation from the newly burning star, pushes against the inner walls of the cocoon with increasing urgency. The way a sleeper shifts and turns as the dream grows too vivid, as the morning outside grows too bright to ignore. And then the cocoon, which has been thick and patient for so long, begins to thin, begins to dissipate. The denser clumps are pushed outward, scattered back into the surrounding space, returned to the interstellar medium from which they came, released to drift again for another million or another billion years before gravity calls them together once more. And as the cocoon thins and finally fully disperses, something extraordinary and simple and almost heartbreakingly beautiful happens. The light gets through. For the first time in the history of this star, which has been building and warming and growing through tens of thousands of years of patient collapse, the light generated in that fusion bright core has a clear path through the surrounding gas, has room to travel outward without being absorbed and re-emitted and scattered endlessly within the shell. It pours outward, not dramatically, not in any single explosive instant that could be witnessed as a flash, but steadily, inevitably, in the way all truly important things happen when you pay close enough attention. The star becomes visible. It takes its place among the points of light that pattern the sky, indistinguishable to the casual eye from all the others that preceded it, and yet utterly new, utterly itself, a thing that was not there before, and now simply, irrevocably, is. There is a quality to that first light that feels worth dwelling on, feels worth turning slowly in the mind before letting it go. Every photon of light that escapes when the cocoon finally disperses has been on a journey already, even before it reaches open space. Born in the core of the star through the processes of fusion, a photon of light does not travel easily or quickly from the center of a star to its surface. It is absorbed and re-emitted, scattered and redirected by the dense plasma that fills the stellar interior in a wandering, stumbling, indirect journey called a random walk that can take hundreds of thousands of years. This single photon of light that was born in a moment of fusion may have spent longer reaching the surface of the star than some civilizations have existed. And then, upon finally arriving at that surface, at the photosphere, where the stellar material becomes thin enough for light to finally escape, it is launched outward into the openness of space. And when the cocoon is gone, when there is nothing left to stop it, it travels on. It travels outward at the speed that light has always traveled, 300,000 kilometers every second, crossing distances that the mind cannot comfortably hold, carrying within it the record of where it has been, the evidence of fusion and of equilibrium, and of all those long, quiet years of collapse, carrying within it the fact of this star's existence as simply and as completely as a heartbeat carries the fact of being alive. Light years away, that photon might fall upon the photoreceptors of some impossible future observer and become, in that moment of reception, the knowledge of a new star. The information written in its wavelength, in its color, in its particular energy, would tell a story of hydrogen burning into helium, of temperatures at the core reaching 10 million degrees and above, of a balance between gravity and light that has been struck and will hold for a span of time that makes the word ancient seem almost too modest. And so the star, this newly visible, newly stable, newly singing thing, finds its place in the quiet order of the cosmos. It pulls any remaining material into a disk around it. It warms the space nearby. It begins the long, slow, generous work of being a star, of fusing and radiating and balancing, of being one small fixed point of light in a universe full of them, each one the product of the same ancient patient process, each one a story that began in darkness and cold, and collapse and arrived after all that time, at warmth and brightness, and a kind of sustained luminous becoming, far away. In the spaces between stars, other clouds of gas and dust are beginning their own slow falls inward. Other cores are beginning their own patient warming. But this star, this particular star, is here now, and its light is its own, and the light that escaped in that first shining moment traveled outward in every direction, gentle and unstoppable. The way a long-held breath is finally the light that escaped in that first shining moment traveled outward in every direction, gentle and unstoppable. The way a long-held breath is finally released into a cold and waiting room, and just like that breath, once given to the air, it could not be called back. It simply became part of everything. Part of the space between things, part of the dark, part of the distance. And the star that had released it settled, slowly, beautifully, into something that would last longer than almost anything else in the universe. It settled into balance, into rhythm, into the long, unhurried life of a main sequence star. There is a particular kind of peace that belongs to things that have found their equilibrium. Think of a river that has carved its channel through centuries of stone, no longer rushing or searching, but flowing with the calm certainty of something that knows exactly where it belongs. A main sequence star is something like that river. Having survived the turbulent, roiling chaos of its birth, the gravitational collapse, the rising heat, the moment of ignition, it arrives at last at a kind of cosmic stillness. Not the stillness of emptiness or silence, but the stillness of deep, purposeful activity, the stillness of a heartbeat, the stillness of breathing. And this phase, this long and luminous chapter, is not a brief interlude in a star's story. It is the story. The vast majority of it, the great unhurried middle that stretches across time in ways our minds can barely hold. A star like our sun will spend approximately 90% of its entire lifetime right here in this phase doing exactly this, fusing hydrogen into helium deep within its core, releasing energy. Shining, 90%. If you imagined a human life compressed into a single year, the main sequence phase would be more than 10.5 months of it. Everything else, the dramatic birth, the eventual transformation, the spectacular endings that sometimes follow, all of that would fit into the remaining weeks. The main sequence is not a moment. It is the epoch. It is the long golden afternoon that fills almost all the hours. Our own sun has been living in this phase for approximately 4.5 billion years. 4.6 billion years, to speak it more precisely, though numbers that large have a way of dissolving into abstraction, like trying to count individual grains of sand on a beach while half asleep. So let us try to feel it differently. In all the time that life has existed on Earth, from the very first simple cells drifting in ancient oceans, through the slow unfolding of complexity, through the age of strange ancient creatures in warm, shallow seas, through the arrival of plants and forests and creatures with eyes, through everything that crawled and swam and flew and walked, through the entire history of human beings and every civilization they have ever built. Through all of that, our sun was here, doing what it does now, shining, fusing, steady, and it was already old when the first living thing drew breath on this world. And it will continue for approximately 5 billion more years before this particular chapter of its story begins to turn. 5 billion years from now. A duration so immense, it becomes almost tender in its vastness, like looking at the night sky and understanding that the light reaching your eyes has traveled longer than you can feel. There is something deeply comforting in that thought, if you let yourself rest inside it. Our star is not rushing. It is not burning itself out in some frantic blaze. It is taking its time, the way things that are truly alive tend to do when they are given enough of it. It is generous with its light. It has been generous for longer than the Earth has existed, and it intends to go on being generous for longer still. But not all stars live at this same unhurried pace. This is one of the quiet wonders woven into the structure of the cosmos. That mass, that single quality of how much a star weighs, how much matter collapsed inward during that first great gathering, determines almost everything about how a star will live on the main sequence. It sets the color of its light. It sets the temperature of its surface. It determines how fiercely it burns, how quickly it uses what it has, how long its life will stretch across the dark. The smallest stars, the ones astronomers call red dwarfs, are quiet, dim, and extraordinarily patient. They burn at temperatures that would seem almost cool by stellar standards, and their surfaces glow with a deep ruddy warmth, a red that is more ember than flame. They are miserly with their fuel in the best possible sense, spending it so slowly, so carefully, that some of them will shine for trillions of years. trillions. While our sun measures its life in billions, a small red dwarf measures its life in units of time so large that the current age of the entire universe is still just a fraction of their expected span. They are the tortoises of the stellar world, and they will outlast almost everything else. Then there are the massive stars, the ones that gather extraordinary amounts of matter during their formation. The ones that ignite with such ferocious intensity that they shine blue-white against the dark, brilliant, and almost blinding in their output. A blue supergiant burns hot enough that its surface temperature may reach tens of thousands of degrees, and the light it releases is not gentle amber or warm red, but a fierce cold blue, the color of something burning too brightly to last. And indeed, these stars do not last, not by stellar standards. Where a small red dwarf might shine for trillions of years, a massive blue star may exhaust itself in only a few million, burning through its hydrogen with such extravagance that its main sequence life is almost startlingly brief. They are the hummingbirds of the universe, astonishing, dazzling, gone. Our sun sits comfortably between these extremes. It is not the smallest, not the largest, not the coolest, not the hottest. It burns at a surface temperature of roughly 5,500 degrees, and its light is the warm, steady yellow-white that we have known our entire lives. It is, in many ways, an ordinary star. And yet that ordinariness is itself a kind of gift, because a star of our sun's size and temperature and steady nature creates something around itself that the more extreme stars often cannot, a habitable zone. The habitable zone. Even the name carries something gentle in it, something that speaks of shelter and welcome and the possibility of being held. It is the region around a star where conditions are just right, not too hot, not too cold for liquid water to exist on the surface of a world. Liquid water, that particular state of the molecule that makes life as we know it possible, that medium in which chemistry becomes biology, that flowing, patient substance without which the story of living things might never have been told. Around our sun, the habitable zone is where Earth lives. Precisely, beautifully, perhaps improbably, our small blue planet sits within that temperate band, close enough to receive warmth, far enough not to be scorched. In that gentle middle distance where oceans can remain liquid, and rain can fall, and snowflakes can form and melt again in the turning of seasons. And this is perhaps the most poignant thing about the main sequence phase of a star's life, the thing that makes it feel not just scientifically significant, but almost personally meaningful when you sit quietly with it. The habitable zones that main sequence stars create are not fleeting things. They persist. They are sustained for millions and billions of years by the very steadiness, the very equilibrium, the very peaceful rhythmic burning that defines this phase. Life, wherever it has arisen, wherever it may arise elsewhere in the vast dark of the universe, has time to do so precisely because main sequence stars are not hurrying. They are not rushing towards some dramatic conclusion. They are simply being what they are, patient and consistent, maintaining the conditions that make complexity possible, holding the warmth steady across the long, slow years. Think of what patience like that allows. On Earth, the earliest life was microscopic, nearly invisible, almost impossibly simple, and it took hundreds of millions of years just for that simple life to learn to use sunlight directly, to develop the trick of photosynthesis that would change the chemistry of our atmosphere. Then hundreds of millions more years before cells with nuclei. Then more time before the first creatures with more than one cell. then more still, before anything with a backbone, before anything with eyes, before anything with legs that could walk on land. The whole gorgeous, improbable unfolding of life on this planet was possible only because the sun was still here, still shining, still steady, through all of it. It did not hurry. It did not falter. It simply continued. This is what it means for stars on the main sequence to be in the most peaceful, rhythmic phase of their entire existence. The word rhythmic is important here. There is a rhythm to what a star does during these long billions of years. At the core, the pressure of gravity pushing inward and the pressure of fusion pushing outward remain almost perfectly balanced, a balance so precise and so sustained that it produces the constancy we take for granted every morning when the light comes through the window. Astronomers have a word for this balance: hydrostatic equilibrium. And it is one of those scientific phrases that is more beautiful than it first appears. Hydrostatic, as if the star were holding itself in the stillness of deep water, not sinking, not rising, simply floating in perfect suspension. And for billions of years, this is what it does. There is something almost meditative in imagining it. A star in its long main sequence life is not dramatic. It does not erupt or collapse or transform. It breathes in and breathes out through millions of years. At the core, hydrogen nuclei drift close enough together that they fuse, becoming helium, releasing the energy that becomes light. That light begins a journey through the star's interior that takes, remarkably, tens of thousands of years before it even reaches the surface, ricocheting, being absorbed, re-emitted, jostling slowly outward through the dense material of the star's body. And then, finally, it reaches the surface, and it escapes into space, and it travels at the speed of light to wherever it is going. To a planet, perhaps, to an ocean on that planet, to a leaf that opens toward it, to an eye. All of that from the steady, patient work of a main sequence star, simply doing what it does year after year after year, in numbers too large to speak as anything but poetry. When you look at the night sky and find a star, any star, the next one your gaze settles on, you are almost certainly looking at a main sequence star, because they are what most stars are most of the time. The universe is full of them. These patient luminous points, each one holding its balance, each one fusing and shining and warming the space around it. Some burn hot and blue and will be gone in a few million years. Some burn red and cool and will still be here long after our sun has changed. And in between, stars like our sun burn their warm and steady light across billions of years, tending their habitable zones the way a gardener tends a plot of ground, not rushing, not forcing, simply providing what is needed, and trusting that what needs to grow will grow. There is a comfort in understanding this, a deep and almost wordless comfort that settles somewhere in the chest when you truly let it land. We are not here on this planet by accident of a moment. We are here because a star chose, in the language of physics, to be stable, to maintain its balance across time, to hold its warmth consistently enough, long enough, for the slow miracle of life to do what life does when it is given room and warmth and time. We are, in the most literal sense, the children of this patient phase. We are what the main sequence makes possible. And so the star shines, not with drama, not with urgency, but with the deep, unhurried generosity of something that has found its purpose and given itself to it completely. The core fuses, the energy rises, the light escapes. The warmth crosses the distance. And somewhere in the habitable zone, something stirs, something lives, something opens its eyes to the light and calls it morning. This is the long middle of a star's story. This is the epoch of steadiness. This is the phase that makes all the others matter. Because it is the phase in which the universe is given time enough to become interesting. Time enough for planets to cool and oceans to gather, and chemistry to grow curious about itself. Time enough for everything. And for billions upon billions of years, the star simply shone, patient and luminous, the way a candle holds its flame through the long hours of a quiet night, nourishing everything within its reach. Warming planets and moons, and the slow drift of dust that never quite settled into anything, content simply to exist in its brightness, content simply to burn. But nothing, not even a star, can hold its flame forever in quite the same way. There is a moment, and it comes so gradually that even time itself might not notice at first, when something deep inside the star begins to change. Not on the surface, not in the warm outer layers where light is still dancing its long, slow waltz outward into space, but at the very center, in the dense and pressured heart where all the burning has always lived. The core, that ancient furnace, begins to run low. The hydrogen that has been the star's faithful fuel for billions of years, that ocean of atomic possibility that the star has been gently, continuously converting into helium through all the long eons of its middle life, that ocean is no longer bottomless. It has been slowly, steadily, quietly drunk down to its dregs. And when the last of the hydrogen in the core has been consumed, when the fusion reactions that have always pushed outward against gravity's relentless inward pulling begin to falter and then fall quiet, something remarkable happens, something ancient and inevitable, written into the physics of the universe from almost the very beginning. The core, with nothing left to push back against the weight of everything above it, begins to contract. It draws inward, slowly at first, then with increasing urgency, the way a held breath finally gives way. The star's center grows smaller and denser and hotter, compressed by the enormous gravity of all those outer layers pressing down from above. The core squeezes itself tighter and tighter, almost as if the star is trying to find, somewhere in its deepest self, one last source of warmth and stability. And the outer layers, those vast, gossamer regions of gas that have always rested somewhat gently above the core's burning heart, they feel the change. The energy flowing up from below shifts and redirects. The outer layers, paradoxically, do not contract along with the core. Instead, they begin to move in the opposite direction entirely. They expand, slowly at first, like a sleeper stretching after a long, deep rest. And then more and more dramatically, the outer envelope of the star begins to billow outward into space, swelling with a kind of quiet grandeur that is almost impossible to hold fully in the mind. What was once a compact, fierce, middle-aged star begins its transformation into something altogether different, something that astronomers call, with a simple beauty, a red giant. The swelling is enormous. If you were watching from some great distance through the long dark of space, you would see the star slowly over millions of years grow larger than it had ever been. Its diameter stretches to tens of times what it once was, then hundreds of times. What began as a fierce, concentrated point of light becomes something broad and diffuse and deeply, mellowly luminous. Our own sun, which one day will undergo this very transformation, will expand so dramatically that its outer atmosphere will eventually reach outward past the orbits of Mercury and Venus, engulfing them entirely, and may stretch as far as the orbit of Mars itself. Mars, that distant rust-colored wanderer, that quiet desert world sitting out in the cold beyond Earth. The future sun will reach toward it with its expanding breath, a gesture both magnificent and slow and terribly final. There is something deeply melancholy in this swelling, and yet also something that has the feeling of golden late afternoon light. That particular quality of autumn afternoons when the light turns amber and everything it touches seems to glow with a warmth that is somehow richer for being near its ending. A red giant is a star in its golden age, its elder years still giving light, still burning with tremendous energy, but changed now, transformed by time and the slow exhaustion of what it once had in such abundance. And the color of a red giant is one of the most quietly beautiful things the universe produces. As the outer layers expand outward, spreading that same energy across a vastly larger surface area, the surface temperature drops. The star cools as it grows, in the way that a heated room cools when you open all the windows and let the warmth spill out into the night. And as the surface temperature falls, the light that the star produces shifts in its hue. The fierce, pale blue-white light of a young star, or the steady, warm yellow of a middle-aged one, deepens and mellows into something richer. The star begins to glow in deep orange tones, in reddish amber, in the color of old embers, in the color of autumn leaves pressed between the pages of a book. A deep, reddish-orange light that seems less like the sharp brightness of noon and more like the long, warm glow of a fire burning low and beautiful in a quiet hearth. And still, the star is not finished. Even as it swells and cools and turns this deep, dreaming red, something extraordinary is beginning to happen in its innermost regions. The core, remember, has been contracting, squeezing itself tighter and hotter under the weight of all those outer layers. And as the core temperature rises under this compression, it eventually reaches a threshold, a doorway of heat and pressure that opens into a new kind of burning altogether. The helium that has been accumulating in the core, the ash of all those billions of years of hydrogen fusion, begins to fuse. And this is not a simple process. Helium fusion is more delicate, more finicky, more complex than hydrogen fusion. To fuse helium into something heavier, you need not just two particles coming together, but three helium nuclei, 3 alpha particles, colliding and combining in an extraordinarily precise and improbable sequence to form the nucleus of a carbon atom. 3 become 1. Astronomers call this the triple alpha process, and it requires temperatures of around 100 million degrees. Temperatures so extreme that they exist comfortably only in the compressed and desperate heart of a dying star. And from this triple alpha process, carbon is born. Carbon, the foundation of life as we know it on this small blue world, the backbone of every living molecule that has ever existed here, is forged in the deep interiors of aging, expanding stars. The oxygen that fills our lungs arrives by a similar process. Some of that newly fused carbon absorbing another helium nucleus to become oxygen in the flickering, chaotic depths of a red giant's core. Every breath is a kind of inheritance from long-dead stars, and in those sleepy, half-dreaming moments just before you fall away into sleep, it is a strangely beautiful thought to carry with you. that the carbon in your body was once fusing inside the heart of an ancient, swelling, golden red star, somewhere in the long history of the cosmos. Look up into the night sky, if you can, and find the constellation Orion, that great winter hunter that rises in the cold, clear months, tilted grandly across the southeastern sky. At his left shoulder, or perhaps his right, depending on how you learn to see him, there burns a star of unusual and obvious color, even to the naked eye, even without any instrument at all. It glows with a distinctly reddish-orange hue that sets it apart from the blue-white stars scattered around it. This is Betelgeuse, and Betelgeuse is a red supergiant, one of the largest, most dramatic examples of what a star becomes when it has moved past its long, stable middle years and expanded into something vast and ancient and glowing. Betelgeuse is so large that it is genuinely difficult for the human mind to hold the scale of it without something slipping loose. If you were to somehow take Betelgeuse and place it at the position our own sun occupies in our solar system, right there at the center, where our familiar yellow star holds court over its family of planets, Betelgeuse would not merely replace the sun. It would engulf every planet inward from its surface, swallowing Mercury, Venus, Earth, Mars, and reaching out past all of them, extending far enough to engulf Jupiter as well. Jupiter, that enormous, banded, storm-racked giant of a world, a planet so large that more than 1,300 Earths could fit inside it. Even Jupiter would be lost within the interior of Betelgeuse, tucked somewhere inside the star's vast and slowly roiling outer atmosphere, like a small stone dropped into an enormous, slowly breathing sea. This is the scale of what a star becomes. This is the direction in which time carries these luminous, patient, ancient things, away from the compact, brilliant, hydrogen-burning intensity of their middle years and outward into this vast, reddish, slow-burning grandeur that is both more and less than what they once were, larger in size but cooler in surface temperature, broader in their reach but less concentrated in their fire, changed by the long passage of time in the way that all things are changed by it. There is something in the quiet expansion of a red giant that feels, if you let it, deeply familiar. The way a life might move from the concentrated, urgent burning of youth, everything pressing outward, everything striving, everything reaching, and settle gradually into something broader and perhaps more golden, less fierce, but no less luminous, spread more gently across a wider space. The star is not diminished by its expansion. It is transformed. It has simply moved from one kind of being into another, carrying within it still the long memory of all those billions of years of steady burning, the accumulated carbon and oxygen of its inner alchemy, the warmth of its long, patient existence, and the light it sends out into the universe during these elder years has that quality, that golden, late afternoon, amber-lit quality that seems somehow more beautiful for its mellowness, for the way it diffuses itself so broadly across the dark around it. A red giant does not stab at the darkness with a focused, sharp brightness. It glows. It radiates warmth and reddish light in all directions, with the unhurried generosity of something that has moved past urgency, past the need to prove itself by intensity, and has found a different, wider, quieter way of shining. The star Betelgeuse, that great ruddy presence in the shoulder of Orion, has been visible to human beings looking up at winter nights for as long as human beings have looked up. Ancient Egyptians saw it. Hunters in the long-ago dark of the Pleistocene, gathered around small fires on cold plains, might have watched it rise. Every civilization that has ever tilted its face to the heavens has seen the reddish glow of Betelgeuse, and none of them knew what it was. And yet all of them must have felt something in the presence of that warm, deep, reddish light, something that felt different from the cold blue stars around it. Something that had the quality of an ember, of dying warmth, of beauty, that is specifically and precisely the beauty of things that are vast and old and still here, still glowing, still present in the dark. The expanded outer layers of a red giant are thin and tenuous compared to the compressed interior, barely held together by the star's gravity. Wisping outward at their edges in slow stellar winds that carry carbon and oxygen and other newly forged elements out into the space around the star. These winds are gentle and constant, like the star breathing out, releasing into the galaxy the products of all its long inner work, seeding the space around it with the materials that might, one day, after a long enough while, gather into new clouds of gas and dust, and eventually collapse into new stars, new planets, new possibilities. Even in its expansion, even in its aging, the star is giving. It is this quality of giving, of radiating, of spreading, of sending warmth and light, and the products of all its inner burning outward into the surrounding dark, that makes the image of a red giant feel somehow like a kind of grace. Not the sharp, urgent grace of youth, but the slower, more diffuse, more encompassing grace of something that has had time to burn through its first great store of fuel, time to swell and transform and find a new way of being, time to become, quite literally, a different kind of object, a different kind of light in the darkness. And so the star drifts through space in its expanded, reddish billowing form, its core quietly fusing helium into carbon and oxygen in that intricate triple alpha dance, its outer layers stretching further and further into the surrounding void, cooling as they spread, glowing that deep and dreaming reddish amber that seems to hold within it all the warmth of every year the star has ever lived. There is no urgency in it. There is only the slow, majestic, melancholy beauty of something vast and old still giving its light, like an ember glowing its warmest just before the night grows still. The star spread its light wider and wider across the dark, its great patient heart shifting towards something like an ember, glowing its warmest just before the night grows still. The star spread its light wider and wider across the dark, its great patient heart shifting towards something it had never done before. A kind of letting go, slow and inevitable, and in its own way, unutterably beautiful. There is a particular quality to endings that begin gently, not with a crash or a cry, but with a soft exhale, the way a sleeping child turns in the night without waking, the way autumn loosens its first leaf before the others follow. The star we have been watching, this quiet and faithful sun-like wanderer of the cosmos, had burned for billions of years with such steady devotion, and now, at the outermost edges of its life, it began to breathe out in a way it never quite had before. Not violently, not all at once, but in a long, slow, stellar wind, a whisper of matter and light drifting outward into the surrounding dark like smoke rising from a candle that has almost burned down to nothing. You could think of it, perhaps, as something like breathing out a dream. For millions of years, millions, not thousands, a span of time so vast it softens the edges of comprehension. The star would shed its outer layers in this way. Gradually, patiently, the way a river softly carves a canyon through patient repetition rather than sudden force. The outer shells of gas, those enormous and ancient atmospheres of hydrogen and helium and traces of heavier things, began to drift free, untethered from the gravity that had held them close for so impossibly long. They moved slowly at first, wandering into the surrounding interstellar space, like mist rolling across an open field at dawn, not quite sure where they are going, only that the distance calls to them. And as they traveled, something remarkable began to happen. Left behind at the star's center, exposed now by the gentle departure of all those outer layers, was the dying core, small, incredibly dense, blazingly hot. The temperature of this remnant rising to extraordinary heights as the outer gas fell away, and that intense heat, that deep and concentrated glow at the heart of what the star had been, began to pour its radiation outward into the expanding shells of gas surrounding it. The ultraviolet light, intense and silent, flooded into the drifting material and caused it to glow. And so the cloud caught fire with color. This is what astronomers call a planetary nebula, a name that carries with it a kind of charming confusion, a small and human footnote in the long story of cosmic discovery. When early astronomers first turned their telescopes toward these glowing objects scattered across the night sky, they noticed something curious. Many of them appeared round and somewhat fuzzy in the eyepiece, not unlike the disk of a distant planet seen through imperfect glass. And so they called them planetary nebulae, a name that stuck, the way so many accidental names do, worn smooth by centuries of use until no one thinks to question it anymore. The name is, in the careful language of science, a historical misnomer. These clouds have nothing at all to do with planets. They are something altogether more astonishing. The glowing outer garments of dying stars, the shed skin of suns, drifting in luminous rings and shells and tendrils across the dark. There is something gently forgiving about that old confusion, though, something that reminds us that we are all simply doing our best to name what we see from where we stand, with the tools we have at hand, and that the universe is patient enough to wait while we slowly, humbly, learn to understand it more clearly. What those early observers could not have known, squinting through their simple telescopes at those faint greenish disks, was the full magnitude of the beauty they were glimpsing. Because when we turn our modern instruments toward planetary nebulae, what we find is almost impossible to describe without reaching for language that belongs more to poetry than to science. These are not pale or modest things. They bloom, they ripple, they arc through space in symmetrical shells and looping wisps and intricate filaments that catch the stellar radiation and glow in colors that feel, somehow, too vivid to have arisen from nothing more than physics. Take, for a moment, the ring nebula in the constellation Lyra. If you know where to look on a clear summer night, you can find it with even a modest telescope, a faint oval smudge of light hanging among the stars. But bring the full power of observatories to bear upon it, and what you see is breathtaking, a luminous ring of gas glowing in concentric shells of blue and green and gold, layered like the rings of a tree, each one recording a different moment in the long, slow exhale of the star at its center. At the very heart of that glowing ring, almost too small to see, the hot remnant core waits quietly, still pouring its light outward into the expanding shell, still coaxing color, from the drifting gas that was once its outermost self. And then there's the Helix Nebula, perhaps the most hauntingly beautiful of all the planetary nebulae visible from Earth, sometimes called the Eye of God. By those who first encounter photographs of it, the helix stretches across nearly 3 light-years of space. 3 light-years, which means that if you tried to cross it at the speed of light, the journey would take 3 years, and it glows in swirling patterns of blue and orange and deep red that look, in the most astonishing way, like a vast eye gazing back at you from the dark. The intricate knots of gas along its inner edge, each one roughly the size of our entire solar system, glow and ripple in the radiation from the central core. And the whole enormous structure seems almost to breathe, to pulse slowly in cosmic time. To look at such things is to feel very small and very calm at once. These nebulae exist for only a brief moment by cosmic standards, a few tens of thousands of years before the gas disperses too thinly to catch the light, before the remnant core cools and the glow fades, and the cloud dissolves back into the interstellar medium from which it came. Brief, yes, but brief in the way that a piece of music is brief, complete in itself, meaningful in its duration, and leaving something changed in the space after it ends. And what they leave behind, what they give to the universe as they dissolve into the surrounding dark, is perhaps the most extraordinary gift of all. Because these expelled shells of gas are not empty, they are not merely hydrogen and helium, the simple elements of beginnings, carried within them, woven through every drifting filament and every glowing tendril, are the heavier elements that the star forged in the long years of its nuclear burning: carbon, nitrogen, oxygen, and traces of other things besides. Elements that took billions of years and unimaginable heat and pressure to create, held in the quiet interior of the star all that time, and now released into the wider universe, seeded into the surrounding interstellar medium, like something being handed down from generation to generation. Carbon, the element of life itself, the backbone of every organic molecule, the scaffold upon which biology builds its impossible complexity. The carbon in your body, in the cells of your hands, resting quietly on the blanket, in the slow movement of your breath, was forged inside a star. It traveled as these expelled shells travel through the dark of interstellar space, enriching the clouds of gas and dust from which new things would eventually be born. Nitrogen, too, the nitrogen that makes up the greater part of the air you are breathing at this very moment, gently filling your lungs in the dark, was given to the universe by dying stars just like this one, scattered into the interstellar medium in the slow and generous dispersal of a planetary nebula. And oxygen, the element that ties itself to hydrogen and makes water, that fills the oceans and the rivers and the clouds, that makes possible the blue of the sky and the rust on old iron and the slow work of breathing. Oxygen was carried outward in just such a drifting shell of stellar gas, released into the universe to mix and mingle with the vast clouds between the stars, waiting to find its way into something new. When astronomers say that planetary nebulae enrich the interstellar medium, they are stating a precise and scientific fact, but they are also describing something almost unbearably generous. These dying stars, in the long, slow dispersal of their outer layers, are giving everything they have accumulated across billions of years back to the universe, not hoarding what they made, not holding it locked in the gravity of their remnant cores, but breathing it outward freely into the dark where it will cool and drift and eventually be gathered up again by the great slow processes of gravity and time, drawn into new clouds, new stars, new worlds, new possibilities. The universe is extraordinarily good at recycling. Nothing is wasted. Every atom that was ever forged in the nuclear heart of a star goes somewhere, does something, becomes part of something else in an endless chain of transformation that stretches from the first moments after the Big Bang to this present moment, this quiet room, this soft and sleepy night. And there is something deeply comforting in that, if you let yourself feel it. The idea that what seems like an ending is simply a transformation, that the great, slow dispersal of a planetary nebula is not a loss, but a redistribution, not a death, but a sending forth, not a silence, but a message written in the language of atoms and carried outward on the wind of a dying star into the waiting dark. The shell of gas drifts and glows and slowly, gracefully loses its brightness. The core at its center, cooling now, will become something else, something quiet and enduring that we will speak of another time. But the elements, the precious cargo of carbon and nitrogen and oxygen, are free now. They have been released into the interstellar medium, into the great between spaces of the galaxy, where future things are waiting to be born. Somewhere in the slow movement of those drifting shells is the oxygen that would one day fill a pair of lungs. Somewhere in those glowing filaments is the carbon that would one day write a poem, build a forest, dream a dream. The universe does not rush this process. It has time. It has patience far beyond anything we can measure. It simply allows the elements to move slowly through the dark, from one form to the next, from one story to the next. The ring nebula glows on in Lyra. The helix continues its vast, slow expansion in the direction of Aquarius. And between them, and among the countless other planetary nebulae scattered across the galaxy like luminous breath, each one a sun's last generous exhale. Each one a treasury of life's ingredients carried outward into the dark. The interstellar medium grows a little richer, a little more ready for the next chapter of the universe's patient and remarkable story. It is enough, perhaps, to close your eyes for a moment and simply feel the weight of that generosity, to breathe in and know that the oxygen entering your lungs once drifted in a glowing shell of gas around a dying star, to exhale and imagine the quiet rings of light expanding outward across the dark in all the planetary nebulae burning unseen above you tonight. Gorgeous and slow and utterly unhurried in their cosmic task, the star gave everything it had to the dark, and the dark, as it always does, held it gently and carried it forward. And as those luminous veils of gas drifted outward into the interstellar dark, carrying within them the very atoms that would one day become oceans and forests and sleeping, and as those luminous veils of gas drifted outward into the interstellar dark, carrying within them the very atoms that would one day become oceans and forests and sleeping children breathing slowly beneath wool blankets, something remained. Something stayed behind, at the very heart of all that gentle letting go. A remnant persisted, quiet, dense, and extraordinary in ways that are almost impossible to hold inside the human mind without feeling a kind of reverent hush settle over everything. Picture it now, if you can, as you feel the weight of your own body sinking softly into whatever holds you tonight. Picture a star very much like our own sun, a warm and patient thing that spent the better part of 10 billion years doing nothing more or less than shining. It fused hydrogen into helium in its core, then helium into carbon and oxygen, layering those processes one upon another like the chapters of a very long and very quiet book. And then, when all those chapters had been written, and all that fuel had been transformed, the star exhaled. It breathed out its outer layers in that slow and glowing exhalation we spoke of before, those shimmering planetary nebulae spreading their colored light across hundreds of thousands of years, thinning and cooling as they went, becoming eventually just part of the great interstellar medium, the raw material of future things. But at the center, once all of that outward drift had happened, once the star had finished its long and graceful shedding, what remained was the core, the innermost part, the part that had done all the real work for all those billions of years, the part that had held the pressure and the heat and the furious alchemy of stellar fusion, and that now found itself suddenly alone, no longer crushed by the weight of the star's outer layers pressing inward, no longer engaged in the constant negotiation between gravity pulling everything together and the outward push of nuclear fire holding everything apart. That negotiation was over. The fire was done. And what sat in the emptied center was something new, or rather something old made newly visible, a white dwarf. Linger with that name for a moment. White dwarf. There is something almost endearing about it, something that suggests smallness and paleness and a kind of faded dignity. And in a sense, all of those suggestions are true. After a star has lived its enormous life and shed its brilliant outer veils, the white dwarf that remains is, by the standards of stars, small, roughly the size of Earth. Our Earth. That small blue world you are resting on right now, the one turning so slowly beneath you in the dark. A white dwarf is approximately that size. And yet, inside that Earth-sized sphere is packed approximately half the mass of the original star, half the mass of something that was once 1,000,000 times larger than Earth, now compressed into a volume barely larger than our own small world. Try to let that settle. Try to let the numbers find their place somewhere gentle in your mind without demanding too much of you, because numbers like these are not really made for waking, effortful thought. They are better absorbed slowly, the way starlight is absorbed by sleeping skin. Half a stellar mass in an Earth-sized volume. The density this produces is almost beyond the reach of ordinary imagination. Scientists speak of it in terms that sound like poetry, even when they are being perfectly precise. And one of those terms is this: a single teaspoon of white dwarf material. If you could somehow bring it here, if you could somehow hold it in a spoon above your sleeping face, would weigh approximately 5 tons. 5 tons in a teaspoon. The stuff of which this quiet remnant is made is so compressed, so extraordinarily packed together, that the familiar rules of earthly density simply dissolve in the face of it. And yet the white dwarf is not frightening. Nothing about it, once you know it, feels threatening or violent. It is, in its way, the most peaceful state a star can achieve. Because unlike every other phase of a star's existence, the white dwarf is not doing anything. It is not fusing. It is not burning. It is not negotiating between gravity and fire, or expanding, or contracting, or erupting, or exploding. It is simply sitting, simply existing, simply radiating away the stored heat of all those billions of years of fusion, very slowly, very gently, like a stone that was pulled from a fire long ago and is still warm to the touch long after the flames have gone. That warmth is not new. The white dwarf makes no new heat, produces no new energy through nuclear processes. What it has, it had. What it releases now is only what it stored. the residual thermal energy of its entire stellar life, drifting outward at last without urgency, without crisis, without drama of any kind. This slow release of stored heat will take a very long time, longer than long. The kinds of timescales involved here are among the most humbling in all of science, and they press gently against the edge of what the human mind can truly feel, rather than merely know. A white dwarf will radiate away its heat over trillions of years. Not billions, trillions. Our universe is currently somewhere around 14 billion years old, which sounds ancient and is ancient, and yet 14 billion years is to a trillion years as a single quiet night is to several thousand years of nights. The white dwarf has barely begun its cooling. Every white dwarf we have ever observed, every one we have found scattered across the galaxies, like slowly dimming embers across a vast and cooling hearth, is still warm, still glowing, though faintly, still carrying within its dense and silent interior the heat of its former fire. And somewhere at the end of all that cooling, somewhere so far in the future that our universe as it currently exists cannot even be said to have made a beginning on the journey there, something will happen that has, as far as we know, never yet happened anywhere in the observable universe. The white dwarf will finish cooling. It will radiate away the last of its stored warmth into the surrounding dark, and it will become something else. Something that as of this moment in cosmic history does not yet exist anywhere at all, a black dwarf. A black dwarf. Say it softly, the way you might say the name of something you have only read about, something that lives only in theory and in the patient mathematics of physics, something that has no example yet to point to, no specimen in any catalog, no signal in any telescope. A black dwarf would be a white dwarf that had simply finished its long cooling, that had reached at last the same temperature as the surrounding universe, that had given everything away and had nothing left to give. It would be dark, it would be cold, it would be roughly Earth-sized and incomprehensibly dense and utterly invisible against the dark, a remnant of a remnant, the final quietest form of a thing that was once a star. But here's what stops the breath a little. What makes a certain kind of wonder rise even in the quietest mind? No black dwarfs exist yet. Not one. The universe is simply too young. The 13 or 14 billion years that have passed since the beginning of everything are not enough time for even the oldest white dwarfs to have cooled into darkness. They are all still warm, all of them. Every white dwarf in every galaxy is still in the early stages of its long cooling, still has trillions of years to go before it reaches that final dark equilibrium. We live in a universe that is, in this particular sense, very young. Young enough that its embers are all still glowing. Young enough that the night has not yet grown cold enough to extinguish even the oldest of its slow and patient fires. There is something deeply comforting in that if you let yourself feel it. The universe is not yet old enough to have any truly cold remnants of sun-like stars. Every stellar core that has settled into white dwarfhood is still holding its warmth, still quietly shining in its small and dense and dignified way, still carrying the memory of its nuclear life as stored heat that seeps outward so slowly it can barely be measured against the scale of a human lifetime. We will never see a black dwarf. Our sun will not become a white dwarf for another 5 billion years or so, and then that white dwarf will need trillions more years to cool into darkness. No human civilization, No descendant of anything alive on Earth tonight will ever witness the final cooling of a white dwarf into a black dwarf. And somehow that is not sad. Somehow it feels more like the assurance of a very long continuity, a reminder that the universe is still early in its story, that the embers are still glowing, that the warmth has not yet left. Think about the white dwarf now as you feel yourself growing heavier and softer in the dark. Think about it not as a death, but as a resting, a star that gave everything, that transformed hydrogen into helium, into carbon and oxygen, and distributed those gifts outward to the cosmos, that glowed for billions of years, with a warmth and steadiness that we who orbit a similar star know something of firsthand. That star, at the end of all its giving, does not vanish. It settles. It compresses its remaining self into something small and dense and extraordinarily still, and it simply rests there in the dark, slowly releasing the last of its warmth over a span of time so vast that even the universe hasn't gotten far into it yet. The white dwarf does not fuse. It does not create. It does not transform. It only slowly, gently, over unimaginable timescales, shares what warmth it has left with the surrounding dark. And the surrounding dark accepts it without hurry, without demand. The cooling happens at its own pace, in its own time, according to no schedule that any urgency could hasten. There is in the white dwarf a kind of ultimate permission to simply be what you are without producing anything new, without transformation, without the pressure of ongoing process. Just existing, just being dense and warm and quiet in the space between stars. Astronomers can measure the temperatures of white dwarfs, and from those temperatures, calculate how long the cooling has been going on, how long since the star shed its outer layers and the core was left to its long stillness. They are like geologists reading the cooling of ancient stone, or like someone pressing a hand to the side of a hearth long after the fire has been let to die, feeling the warmth still there and knowing by its intensity how many hours have passed. Every white dwarf tells a story through its temperature, a story of how long it has been resting, how long since the fire went out, how many billions of years of gentle cooling have passed since it became what it is now. And what it is now is quiet. What it is now is small and brilliant and enormously dense and very, very slowly dimming. Somewhere in the galaxy, in fact, in many places in the galaxy, these gentle embers drift through the dark between stars, not going anywhere in particular, cooling by the barest fraction of a degree over millions of years, surrounded by the silence of space, holding within their packed and extraordinary interiors the compressed record of everything they once were. All that carbon, all that oxygen, the product of billions of years of stellar alchemy, now simply sitting still, no longer being processed into anything, no longer climbing the periodic table, one fusion reaction at a time, just there, just present, just warm, resting now in the velvet dark of space, no longer burning but still quietly warm. The white dwarf held all its memories of fire within a silence as deep and soft as resting now in the velvet dark of space, no longer burning but still quietly warm. The white dwarf held all its memories of fire within a silence as deep and soft as the space between sleeping and dreaming. And yet, not every star earns such a quiet retirement. Not every stellar life fades into that gentle, dimming ember glow. Some stars are born too large, too hungry, too magnificent for such a peaceful end. Some stars are written from their very first moments in a language that only knows how to conclude in fire, and what a fire it is. a fire so enormous, so brilliantly total, that the universe itself seems to hold its breath in something like wonder. Let us drift now toward those other stars, the grand ones, the ones born enormous, blazing through their hydrogen and helium and carbon and oxygen at a pace that makes our own sun look leisurely by comparison. These are the stars that weigh more than 8 times the mass of our sun, and often far more than that. Enormous celestial furnaces that burn so fiercely that they consume in millions of years what a smaller star might sustain across billions. They are prodigal, extravagant, magnificent. They pour their light into the universe with a kind of reckless generosity, and the universe is more beautiful for it, even knowing that such generosity cannot last. Imagine, if you will, one of these great stars in its prime. Perhaps a blue supergiant, luminous beyond imagining, its surface blazing at tens of thousands of degrees, its light so fierce that it could push the very gas around it outward through sheer radiation pressure alone. It sits at the heart of a stellar nursery, perhaps, having been born from a cloud of gas and dust billions of years before you or I arrived to look up and wonder at it. It has been burning steadily, working its way through the periodic table of elements in its core, like a slow reader turning pages. Hydrogen to helium, helium to carbon, carbon to neon, neon to oxygen, oxygen to silicon. Each fusion reaction releasing energy, each layer of ash becoming the fuel for the next, deeper fire. The star builds up its interior in shells, like the layers of a great cosmic onion, and at the very center of all those shells, the innermost layer, the most compressed and most processed. What remains is iron, and iron is where the story changes. Iron is where the story ends, in one way, and begins in another. You see, iron is different from all the other elements a star has burned through. Every other fusion reaction, hydrogen into helium, helium into carbon, all the long chain of nuclear transformations releases energy when it happens. The star gets something back from the process. But iron is the end point of all that giving. Iron does not release energy when it fuses. Iron absorbs it. To fuse iron into anything heavier costs more energy than it yields, and so the star finds itself, after all those millions of years of magnificent burning, in an impossible position. The fire cannot continue. The iron core cannot sustain itself, and the star has built up an iron heart that is simply fundamentally wrong for the job of keeping it alive. For a moment, and we mean this almost literally, almost on the scale of a breath, of a heartbeat, of a single blink in the long, slow dream of cosmic time, the star holds itself in balance. The weight of all those outer layers pressing inward, the pressure of the iron core pressing outward, a tension that has lasted perhaps days or weeks as the iron core has been quietly growing, quietly reaching the point at which it can no longer resist. And then the moment arrives. The iron core, having grown too massive and too cool to support itself, collapses. What happens next happens in less than a second, less than 1 second. Think about that, gently, as you rest here in the quiet. The entire iron core of a star, a sphere of material, perhaps the size of Earth, packed with the mass of the sun, compressed beyond any density we encounter in ordinary life, collapses inward in less than 1 second. The material at the center is compressed so tightly that protons and electrons are forced together into neutrons, releasing a torrent of ghostly particles called neutrinos. particles so small and so shy that they can pass through the entire Earth as if it were no more substantial than a whisper of fog. Those neutrinos carry away an almost incomprehensible amount of energy, more energy than our sun will radiate across its entire 10 billion year life, released in that single collapsing heartbeat. The collapse of the core sends a shockwave outward. A shockwave unlike anything else in the universe, moving outward through the star's layers at a significant fraction of the speed of light, carrying the energy of that catastrophic implosion outward, through the shells of silicon and oxygen and neon and carbon, through the outer layers of helium and hydrogen, unraveling the star as it goes, destroying in hours and days what had been built over millions of years. The star does not merely die. The star explodes. The star becomes a supernova, and the light. Oh, the light that is released in that moment. The light that travels outward from the site of the explosion, crossing the vast distances between stars, arriving eventually at whatever eyes might be waiting to receive it. For a brief, blazing, astonishing moment in cosmic time, a supernova can outshine an entire galaxy. Not one star, not a cluster of stars, not even a stellar nursery filled with thousands of new bright lights, but an entire galaxy of hundreds of billions of stars. A single dying star in its final act, briefly radiating more light than all those hundreds of billions of suns combined. The universe does not do things by halves, and it does not let its grandest stars depart quietly. There is a story written in the sky about exactly this. A true story, observed and recorded by patient human eyes looking upward through the clear night air, long before telescopes existed to help them. In the year 1054 of the Common Era, astronomers in China noticed something strange and extraordinary in the sky. A new star had appeared, a star that had not been there before, blazing in the constellation we now call Taurus, in the region of space where a massive star had been quietly, invisibly completing its long life. The astronomers recorded it in their careful chronicles, noting its brightness, its position, the way it appeared without warning, and then lingered, gradually fading. What they had witnessed, though they had no way of knowing it then, was the death of a star, a supernova, an explosion that had actually occurred nearly 6,000 years earlier, the light simply needing all that time to cross the space between that dying star and the wondering eyes of those Chinese astronomers. And that light, that ancient light from that ancient death, was bright enough to be seen in full daylight, not just visible in the night sky, not merely a bright point among the stars when the sun had set and darkness fell, but visible in the middle of the day, competing with our own sun for presence in the sky. For 23 days, the supernova could be seen in daylight. 23 days during which anyone who looked up at the right part of the sky, even in the full brightness of afternoon, would have seen that extra point of light hanging there. Brilliant and impossible, as though the universe had decided to add a second sun, briefly just to remind the watching Earth how extraordinary things could be. For nearly 2 years after that, the supernova was visible in the night sky, before it finally dimmed and faded, and where it had blazed, there remained a cloud of expanding gas and dust, a nebula that is still there today, still expanding, still carrying outward the material of that exploded star. We call it the Crab Nebula now, and when astronomers photograph it, they see a tangle of glowing filaments, the ghost of a star still slowly dissipating across the light years, still spreading its substance into the surrounding space, with an unhurried, beautiful momentum that nothing can now stop. Because that is the other extraordinary thing about supernovae. They are not merely spectacular deaths. They are the universe's great generosity toward the future. A star that lives and dies quietly. A star like our white dwarf, slowly cooling in the dark, takes its material with it into that long silence. But a star that explodes in a supernova scatters itself across space, and in the tremendous heat and pressure and energy of that explosion, something remarkable happens. Elements are forged that cannot be made any other way. The heaviest elements, those that sit high and heavy in the periodic table, those that require more energy to create than even the most furious stellar core can provide, are created in the violence of the supernova itself, in the shock wave, in the extraordinary compression and heat of that fleeting, brilliant moment. Gold, silver, platinum, uranium, all the precious and weighty elements that humans have treasured and used and wondered at since the earliest moments of civilization. None of them were born in a quiet place. None of them were gently made. They were forged in the most violent event that the universe knows how to produce outside of its own birth, hammered into existence in a detonation that briefly outshines galaxies, released into space as the dying star's final, overwhelming gift to everything that comes after. And then those atoms drift, slowly, gently, over millions of years, those scattered atoms of gold and silver and platinum and all the other elements synthesized in that explosion spread through the surrounding space, mixing with clouds of hydrogen and helium, mingling with the remnants of other stars, becoming part of the great slow fog of the interstellar medium that drifts between stars and waits, with infinite patience for conditions to change, for a cloud to begin to collapse, for gravity to begin to gather, for the long, slow, beautiful process of star formation to begin again, incorporating now these heavy atoms into new stars, new planetary systems, new worlds where perhaps those atoms might find their way into something that breathes and thinks and looks up at the night sky and wonders where it all came from. There is something almost unbearably poetic about that chain of events, if you let yourself feel it while lying here in the dark. The gold that might rest somewhere near you tonight, in a ring perhaps, or a piece of jewelry, or simply somewhere in the world. That gold was made in a moment of celestial catastrophe, billions of years ago, in an explosion so vast and so bright that it could have been seen from across the universe. And it drifted through space for eons before finding its way into the cloud that became our sun and our planets, into the earth, into the veins of rock from which it was eventually mined, into the hands of human beings who shaped it and prized it, often without knowing its true origin story. Every piece of gold is a tiny monument to a star that died in fire and gave everything it had to the future. And all of this extraordinary violence and generosity and brilliance is contained within those few moments of a supernova's life. The collapse in less than a second, the shockwave unraveling the star, the blazing outburst of light that briefly rivals a galaxy, the forging of the heavy elements, the scattering of those elements into the waiting dark. It happens fast, by cosmic standards. It is brief and shattering and total. And then the light fades, and the material drifts, and what remains at the center, if the conditions are right, is something new and strange, a remnant of the collapsed core spinning in the dark. But that is a story for another moment in our journey tonight. For now, rest in the glow of that image, a star blazing at the end of everything it was, pouring itself into space with total, devastating, beautiful completeness. No quiet fading here, no long cooling in the dark. Just that single, overwhelming burst of light and energy and matter. That gift of heavy elements scattered across the light years. That brief brightness so extraordinary that human eyes on a small blue planet saw it in the middle of the day and wrote it down in their careful records so that we might know it happened. So that we might understand across the centuries what they witnessed when they looked up and saw a new star burning. The universe does not waste its grandest moments. It ensures they are witnessed one way or another. It sends their light across the years, across the light years, across the vast and patient dark, so that someone, somewhere will receive it, will look up, will feel something stir within them that they cannot quite name. That feeling that the universe is larger and stranger and more beautiful than any single mind can hold, and that somehow inexplicably, warmly, they are part of it. And somewhere in the space between stars, in that slow and drifting dark, atoms of gold and silver and platinum continue their long wandering journey, carrying within them the memory of fire, the record of an explosion, the evidence of a moment so bright it defied the night itself, moving through the dark towards some destination they do not know, toward some future they cannot see. And in that single breathtaking instant of celestial fire, elements forged in the deepest furnace in the universe were released into the void, drifting toward futures they could not yet imagine. And yet, what remained behind was perhaps the most astonishing thing of all. Not the scattered light, not the blooming nebula of expelled gas and glittering dust. Not even the newly minted atoms of iron and gold and uranium now sailing outward into the patient dark. What remained behind in the very center of where the star had been was something so extraordinary that even the language of science struggles to find adequate words for it. Something so compressed, so impossibly dense, so quietly ferocious in its nature, that it seems to belong more to the realm of dreams than to the physical world we think we understand. Let yourself settle a little deeper now. Let your breathing slow. What we are about to consider together is one of the strangest and most beautiful objects in the entire known universe. And there is something deeply calming about simply allowing the mind to rest in the presence of such strangeness, to stop grasping for full understanding, and instead just float, gently, in the soft astonishment of it. After the supernova, after the fire and the fury and the light that briefly outshone entire galaxies, the collapsed core of the original star did not disappear. It did not vanish into nothing. Instead, it remained crushed beyond anything our ordinary intuitions can comfortably hold, pressed inward with such extraordinary gravitational force that the very atoms within it cease to be atoms in any recognizable sense. The electrons, which in ordinary matter orbit their nuclei like small faithful companions, were pushed inward, driven into the protons themselves, and in that merging, they became neutrons. An entire object, something we could in principle walk around if we could somehow survive being near it, made almost entirely of neutrons packed so closely together that the word density loses all familiar meaning. This is the neutron star, a city-sized remnant of what was once a sun, many times more massive than our own, only about 20 kilometers across, a distance you might drive in less than 15 minutes on an empty highway, and yet containing within that impossibly small sphere up to twice the mass of our entire sun. All of that mass, all of those tons beyond imagining, compressed into a space no larger than a modest earthly city, sitting quietly in the dark, spinning, pulsing, radiating, existing in a way that defies the comfortable categories of our experience. Take a breath. Let that settle without needing to fully resolve itself into sense. Some things are meant to be held loosely, like a pebble in an open hand, felt without being fully grasped. Consider, for a moment, just a single teaspoon of a neutron star. Not a bucket full, not a mountain's worth. Just a teaspoon, the kind of small silver spoon you might use to stir a cup of tea before bed, delicate and ordinary and warm in the hand. A teaspoon of neutron star material would weigh approximately 4 billion tons. 4 billion, not millions, billions. More than the combined weight of every human being who has ever lived on this earth, multiplied beyond comprehension, sitting in that tiny silver bowl of a spoon. The earth itself, were you somehow able to place it on a scale beside that teaspoon, would seem almost trivial by comparison. The ground beneath you right now, the bedrock and the mantle, and the iron core at the center of our world. All of it seems almost airy when measured against what a neutron star has achieved in its quiet compression. And yet, for all its unfathomable density, for all the crushing gravity that shapes it into a sphere of pure neutron matter, perhaps covered by a thin crystalline crust of strange exotic atomic forms. The neutron star is not simply sitting still, not at all. Many of these objects are spinning, and they are spinning in a way that makes even our most precise earthly machinery seem clumsy and approximate. Picture a lighthouse on a rocky coast at night. You cannot quite see the lighthouse from where you are. Perhaps you are out on the dark water, rocking gently in a small boat. The stars above you reflected in the slow black swells, and every few seconds, a beam of light sweeps across you. Regular, rhythmic, patient. That beam tells sailors where the rocks are. It tells them where the danger lies. It speaks in the language of repetition, of the reliable interval, of the pulse that can be trusted. Now imagine that lighthouse spinning not once every few seconds, but hundreds of times every single second. Imagine that beam sweeping past you, not in the leisurely rhythm of a coastal light, but with a speed that blurs all distinction, that becomes almost a continuous presence in its rapid recurrence. This is something close to what a pulsar does, and a pulsar is simply a neutron star whose rotation brings its beams of radiation into alignment with our line of sight as it spins. Like a cosmic lighthouse in the truest sense, it sweeps its beams of radio waves, or X-rays, or gamma rays through the galaxy, and if we happen to be positioned correctly, we receive those pulses as a heartbeat, a tick, a rhythm, so precise it seems almost deliberate. The fastest known pulsars spin over 700 times per second. 700 complete rotations in a single second. In the time it takes you to blink, such a star has rotated dozens of times. In the span of a single quiet breath, hundreds. And these rotations are not sloppy or approximate. They are not like a wobbling top, losing its momentum on a table. They are measured to be more precise in their timing than atomic clocks. Those extraordinary human instruments we use to define our finest standards of time. The pulsar outperforms our best technology, not by a little, but by a character of precision that feels almost philosophical, as though time itself is more at home in the fabric of a neutron star than it is in any laboratory we could build. There is something both humbling and strangely comforting about that. To know that out there in the dark, in the ancient quiet between the stars, objects are spinning with such faithful precision that they could in principle serve as the most accurate clocks in the universe. There is a steadiness in that thought, a reliability. The cosmos, for all its violence, for all its explosions and collisions and chaotic beginnings, also produces this, the perfect tick, the unwavering pulse. Let your mind drift with that for a moment. You do not need to understand it completely. You only need to let it rest beside you in the dark. The way a distant sound of rain can be comforting, even when you cannot see the rain itself. And then there's the matter of the magnetic field. If the density and the spinning have not yet stretched the imagination far enough, consider what surrounds a neutron star in terms of its magnetic presence. The Earth has a magnetic field, that invisible architecture of force that guides compass needles and shapes the auroras at the poles. That gentle planetary halo of magnetism that has oriented navigators and migrating birds across the ages of this world. It is subtle and real, and woven quietly into our experience of life on this planet. The magnetic field of a neutron star is approximately 1 trillion times stronger than that of the Earth. 1 trillion. The number floats free of any comfortable anchoring. There is no everyday object, no familiar comparison that quite captures the distance between Earth's magnetic presence and the magnetic ferocity that surrounds a neutron star. At the surface of such an object, in the extraordinary conditions shaped by that magnetic force, matter itself behaves in ways that have no parallel anywhere else in the universe, as far as we know. The atoms, to whatever limited degree atoms can be said to still exist at the surface of a neutron star, are stretched into elongated forms along the magnetic field lines, compressed and distorted into configurations that have no earthly name, that exist in a realm of physics that our equations can gesture toward but our intuitions cannot follow. The very nature of matter, the fundamental character of what it means for something to be made of particles and forces and fields, is reshaped in that environment into something alien and magnificent. And yet, for all of this, the neutron star persists. It does not announce itself with drama in the way the supernova did. It does not blaze across the sky or scatter its substance into the cosmos. It simply is. It rotates. It pulses. It waits in the patient dark with its crushing density and its trillion-fold magnetic embrace and its rhythms more reliable than any clock we have ever constructed. Some neutron stars are alone, orbiting no companion, drifting quietly through the galaxy in the long afterglow of their violent birth. Others are paired with other stars, drawing material from their companions, sometimes building toward further transformations that we will not follow here, not tonight. Some are born in the precise conditions that produce those extraordinarily rapid millisecond pulsars, spun up to their incredible rotational speeds over long periods of mass transfer. Like a top that has been wound tighter and tighter over millions of years until its spin has become something vertiginous and absolute. Think of what the birth of a pulsar represents across the stretch of time. A star lived its life over millions of years, burning hydrogen, then helium, then heavier and heavier elements in its layered interior. It ended in fire and light that briefly lit the surrounding region of the galaxy, and from that fire something emerged that would spin reliably and precisely for billions of years to come. The violence of the beginning giving way to the extraordinary steadiness of the continuing. There is a kind of narrative in that, a long story that moves from turbulence into something resembling serenity. Though a serenity so dense and so intense that no living thing could ever approach it and survive. Still, the metaphor is there if you want it. The wildness settling in time, into rhythm, the explosion giving way to the pulse, the chaos of formation collapsing into a spinning, steady, reliable something that keeps its own time against the turning of the galaxy. Feel the quiet of that. There is something almost meditative in the image of the pulsar out there in the dark between the stars, spinning in its perfect intervals, emitting its beams like the turning of an impossibly precise and impossibly remote clock face. You will never see it with the naked eye. It is too far away. Its light distributed across wavelengths your eyes were not designed to receive. But somewhere out there, it is spinning right now as you read these words, as your breathing slows, as the edges of waking begin to soften into something else. It was spinning before any human eye ever looked up at the night sky. It will be spinning long after the last human thought has faded into the silence that follows all thoughts eventually. There is a kind of company in that, if you choose to feel it. The universe keeping time even when no one is listening. The neutron star indifferent to whether it is observed or not, faithful to its rotation, not out of purpose, but out of the simple physics that governs it. The way water flows downhill, not from intention, but from the shape of things, the elegant obedience of matter to the laws that hold it. You might let your own breathing find a rhythm now. Something slow, and even something that does not need to keep up with 700 rotations per second, but can settle into its own, much gentler pace. One breath in, one breath out. The body finding its own kind of pulse, its own kind of reliability. Here in the dark, that is not the dark between the stars, but the warm and ordinary dark of wherever you are tonight. And out there, unreachably far, across distances that light itself requires thousands of years to cross, spinning in the dark at the edge of all comprehension. The neutron star kept its perfect time like the heartbeat of the universe itself, steady beyond all imagining, as though even time had decided to simply spinning in the dark at the edge of all comprehension. The neutron star kept its perfect time like the heartbeat of the universe itself, steady beyond all imagining, as though even time had decided to simply rest against its surface and breathe along with it, surrendering to the rhythm of something far older and far denser than ordinary matter had any right to become. But not every story ends in that kind of equilibrium. Not every collapsing core finds its footing on the narrow ledge between destruction and survival. Some falls go deeper. Some silences go further than even the neutron star's crystalline stillness can reach. And when the mass of what remains after a stellar death climbs above a certain threshold, when the remnant left behind weighs more than roughly 3 times the mass of our own sun, there is no force in the known universe capable of holding it up. Not electron pressure. Not the fierce repulsion between neutrons. Nothing. Gravity, that most patient and ancient of forces, the one that shaped galaxies and drew the first hydrogen clouds into the first bright fires, simply wins. Completely, irrevocably, and in winning, it creates something that even now, after decades of observation and centuries of mathematics, still feels more like myth than physics. It creates a black hole. Breathe that phrase in slowly. Let it settle like a stone dropped into still water, sending rings outward through your imagination. A black hole. The word suggests emptiness, an absence, a hollow place in the sky where something used to shine, and in a way that is true, where once there was a star, perhaps a star 20, 30, 50 times more massive than our sun, burning blue-white and furious at the center of its own small cosmos. There is now something that gives off no light at all, something that does not gleam or pulse or flicker, something that, if you were floating nearby in the quiet of space, you might not even see directly. You would only know it was there by what happened to everything around it. By the way light bent, by the way nearby matter spiraled, by the way time itself began to slow and stretch and lean toward a center it could never quite reach. At the heart of a black hole, if heart is even the right word for something so extreme, lies what physicists call the singularity. It is a point, or something we approximate with the concept of a point, because our language runs out of precision here, where the mass of the original star has been compressed into a region of theoretically infinite density. Infinite. Not very dense, not impressively compact, not record-breakingly small, but infinite in the mathematical sense, which means that every equation we have ever written, every law of physics we have ever trusted, every framework we have ever used to describe how reality behaves, quietly and completely breaks down. The singularity is where our understanding reaches its edge and looks over and finds only silence staring back. It is, in the most literal and profound sense, the place where the story of known physics ends and something else, something we do not yet have words or equations for, begins. And surrounding the singularity, like the last gentle shore before an ocean with no far side, is the event horizon. This is perhaps the most hauntingly beautiful concept in all of modern science, and yet it sounds so mild when you first hear it. A horizon. We know horizons. We have watched them from beaches and mountaintops, watched the sun sink behind them, watched them recede as we walk toward them, always the same distance ahead. A horizon is a boundary defined by perspective, not by physics. You can cross an ordinary horizon simply by moving forward. But the event horizon of a black hole is something different, something final. It is not a physical surface, not a wall, not a membrane you could touch or see or feel as you approached. If you were falling freely toward a black hole, you might cross the event horizon without any immediate sensation at all, at least not according to some interpretations of relativity. But the moment you crossed it, something irreversible would have happened. The event horizon is the boundary beyond which nothing, not matter, not energy, not a whisper, not a thought, not a single photon of light can ever escape. Whatever falls past that invisible line becomes part of the black hole's secret, carried inward forever, contributing its mass and its story to the growing silence at the center. Not even light. Let that float through your mind gently, the way a feather settles through still air. Light, the fastest thing that exists, the thing that crosses the entire solar system in minutes and the entire observable universe in the span of cosmic time, cannot outrun the curvature of space-time inside the event horizon. It tries, in a sense. It moves at the only speed it knows how to move. But space itself is falling inward faster than light can travel outward, and so light simply goes inward with everything else. A traveler on a river too swift to swim against. This is the nature of the event horizon. Not a wall, but a current. Not a door, but a direction. Inside the event horizon, all paths through space-time, every possible future, every direction any particle or wave or thought might travel, point inexorably toward the singularity. There is no sideways anymore. There is no backward. There is only the long, inevitable drift toward the center, like a dream that keeps returning to the same room no matter which corridor you choose. And yet, and this is a thing worth pausing over, worth letting soften the image of absolute darkness. Black holes are not the cosmic vacuum cleaners of science fiction. They do not prowl the universe hungrily, pulling in everything within reach. If our own sun were somehow in some impossible hypothetical replaced by a black hole of identical mass, The Earth would not spiral inward. The planets would continue their orbits exactly as they do now, moving in their long ellipses through the dark, tugged by the same gravitational pull they have always felt. Only the warmth would be gone, only the light. The gravity itself would be unchanged. Black holes do not reach out. They simply wait. Matter falls toward them only when it drifts very close, when orbits decay through collision or friction, or the slow dissipation of energy in surrounding gas clouds. Then material spirals inward in great glowing disks, heated by compression and electromagnetic forces until it shines brighter than entire galaxies before finally crossing the event horizon and vanishing. These accretion disks are among the most luminous structures in the universe, screaming with radiation right up to the moment of final silence. But the black hole itself, the singularity and the space it curves, simply waits with extraordinary patience, curving space-time around itself the way a stone curves the water that flows past it, shaping the paths of whatever drifts near without demanding that anything come at all. There is something almost meditative in that, something that feels, in the deepest hours of a quiet night, like a kind of teaching. The most powerful gravitational object in the known universe does not grasp or strain or reach. It simply is, and the world bends around it, and things come to it in their own time, in their own arc. Now imagine that you could wait, that you could find some impossible vantage point outside a black hole, somewhere far enough away to be safe but close enough to watch, and that you had unlimited time. Not a human lifetime, not a civilization's span, not even the current age of the universe, but truly unlimited time. What would you see? You would see the black hole persisting. You would see it curving light from distant stars around its edges, creating those ghostly rings and arcs that astronomers now photograph with global arrays of radio telescopes. You would see it accumulating mass slowly if matter drifted near. You would see it enormous and silent and apparently eternal. But then, if your patience extended far enough, across timescales so vast they make the current age of the universe feel like a single heartbeat, you might begin to notice something extraordinary, something subtle beyond all imagining, something that Stephen Hawking, one of the most remarkable minds our species has ever produced, predicted theoretically in 1974. A prediction so strange and beautiful that it remains one of the most celebrated insights in the history of physics. Black holes, Hawking showed, are not completely black. They glow, faintly, unimaginably faintly, with a kind of thermal radiation born from the strange quantum behavior of empty space near the event horizon. The mechanism involves the ceaseless flickering of the quantum vacuum, the way pairs of particles and antiparticles constantly blink in and out of existence at the very edge of what is real, and the way the event horizon can sometimes separate these pairs before they recombine, allowing one particle to escape into space while the other falls inward. The escaping particle carries energy away from the black hole, and very, very slowly, across timescales that dwarf the current age of the universe by incomprehensible factors, the black hole loses mass. It radiates. It evaporates. A stellar mass black hole would take something on the order of 10 to the power of 67 years to evaporate through Hawking radiation. Numbers that large become almost meaningless to our ordinary minds. Numbers that carry more zeros than there are atoms in the observable universe can hold. They are not quantities exactly. They are more like gestures toward the infinite ways of saying a time so long that time itself will have changed its meaning by then. But the principle stands. confirmed by the internal mathematics of quantum field theory applied to curved spacetime. Nothing, not even a black hole, is truly permanent. Even the darkest, most final-seeming object the universe has ever produced is slowly, quietly, whispering itself into nothing. This is the gift hidden inside Hawking's insight. Not just the prediction of radiation, not just the technical triumph of unifying quantum mechanics and general relativity in even this limited way, but the deeper philosophical implication that comes wrapped inside the mathematics, like a small warm light inside a stone-cold cavern. Nothing is truly final. Even an event horizon, even a singularity, even the object we named after the darkest thing we could imagine, carries within it the seeds of its own eventual dissolution. The universe, it seems, does not permit anything to be absolutely permanent, absolutely sealed away, absolutely beyond the reach of change. The black hole radiates into the dark. It does so slowly that no instrument we have ever built or could easily imagine building would detect it coming from any stellar mass black hole. It does so across timescales that swallow all of human history the way the ocean swallows a raindrop. But it does so. The equations say so. The logic of combining what we know about quantum fields and curved spacetime says so. And there is something extraordinarily comforting about that. If you let yourself feel it in the quiet and the dark, something that settles into the chest, like a long exhale. Even here, even in the deepest dark, even past the edge where light gives up and turns inward, even at the most extreme destination the universe offers to collapsing matter, even there, something is still happening. Something is still changing. Something is still in its impossibly slow way, moving toward whatever comes next. The black hole holds its space in the cosmos. It bends the paths of photons that skim its edges, painting rings of fire against the darkness. It keeps the orbits of whatever stars and dust clouds circle it at safer distances, anchoring their long, slow dances through the dark. It waits with a patience that makes geological time feel hurried, that makes the lifetime of the universe feel like an afternoon, and all the while, across scales of time and distance that our minds can gesture toward but never truly inhabit, it breathes out, ever so gently, the faintest imaginable warmth. Space-time curves most deeply here. Here, at the bottom of the universe's deepest gravitational well, time slows most dramatically, so dramatically near the singularity that the difference between any two moments stretches beyond all ordinary meaning. Here, the distinction between place and time that feels so natural to us blurs and warps until direction and duration become almost interchangeable. Here, at the edge of all our equations, where the mathematics reaches a boundary it cannot cross, the universe keeps its deepest secret behind the most absolute curtain it has ever drawn. And we, small and warm and briefly alive on our small warm planet, have learned to see it, not with our eyes, but with radio waves gathered by telescopes spread across entire continents, coordinated by atomic clocks and connected by mathematics, assembled into images that let us look into the face of a black hole and recognize it for what it is. We have named them. We have measured their masses. We have watched them merge in collisions that sent ripples through the fabric of space-time itself, ripples we detected here on Earth, with instruments sensitive enough to measure a change in distance smaller than a proton's width. We are, in this sense, extraordinarily remarkable, and we are, in another sense, simply part of the same story, the same atoms. The same forces, the same space-time, looking at itself from one curve of the universe, across the dark, toward another. And yet, even in that absolute darkness, even beyond the edge of light itself, there was still something, a slow, quiet evaporation, as though the universe whispered that nothing, not even the darkest ending, was truly final. Nothing was ever truly finished. Nothing was ever truly gone. Think about that for a moment if you can, in that soft place between waking and sleep where thoughts move like water through open hands. Think about how the universe has never once, in all its vast and patient history, thrown anything away. It has only ever transformed. It has only ever handed things forward, from one form to the next, like a long and tender relay, a gift passed between runners who never meet. Across distances so enormous that the word enormous becomes almost meaningless, almost beautiful in its inadequacy. And perhaps the most extraordinary stop along that relay, the most breathtaking handoff in all of cosmic history, is the one that ends inside you. Let us go back, gently, to where it all begins. Or rather, where it begins again, because this is not a story with a single origin. This is a story that folds back on itself like a river that somehow finds its own source, like a breath that becomes the wind, that becomes the breath of something else entirely. This is the story of stellar matter, and it is, quietly and literally, your story too. Long before our sun existed, long before there was a sun to rise or set, long before there was a morning or an evening, or a word for either, there were other stars, ancient stars, some of them far larger than our own, burning with a ferocity that is almost impossible to hold in the mind. These were the first generations, the pioneers of the periodic table, forging in their nuclear hearts the very elements that would one day make complexity possible. Hydrogen had been there since nearly the beginning, spun out of the first few minutes of existence, along with helium and traces of lithium. But everything heavier, everything richer, everything more intricate had to be made, and stars were the furnaces chosen by physics to do that making. Deep inside those ancient stellar cores, where temperatures climbed into the tens of millions of degrees, hydrogen fused into helium, and helium into carbon, and carbon into oxygen. And on up the periodic table in a slow, magnificent ascent. Each step required more heat, more pressure, more of the star giving itself over to the process. These stars burned through their fuel in a kind of gorgeous sacrifice, spending themselves across millions of years, or in some cases, just thousands, climbing higher and higher through the elements until they reached iron. Iron, that strange attractor at the heart of stellar evolution, the element that cannot be fused to release energy, only consumed. When a massive star builds an iron core, it has reached the end of its burning road, and what happens next is one of the most violent and generative events the universe knows how to produce. The core collapses in less than a second. Less than a second after millions of years of burning. The outer layers, suddenly unsupported, fall inward and then rebound in a shockwave so powerful it tears the star apart from the inside out. A supernova, a death that is also, in the most literal sense, a seeding, because in those final moments, in that extraordinary explosion, temperatures spike high enough to forge elements that even the star's long life could not produce. Gold, platinum, uranium, the heavy and precious things that require catastrophe to exist. And then all of it, every atom the star ever made, and every atom forged in its dying is flung outward into space, outward into the dark, outward into the waiting. That material travels. It disperses slowly, over thousands and millions of years, drifting through the interstellar medium in great glowing clouds that we call nebulae. And these clouds are not empty waiting rooms. They are nurseries. Given enough time, given the right nudge, perhaps from the shockwave of another nearby supernova, perhaps from a gentle gravitational ripple in the structure of a galaxy, parts of these clouds begin to contract. Gravity pulls the gas and dust inward. The cloud begins to spin. It heats at its center, and slowly, over hundreds of thousands of years, a new star is born, cradling in its surrounding disk all the material that did not fall into the center. That disk will cool and clump and aggregate into worlds, into planets, into the possibility of standing on solid ground beneath a warming sky. This is not metaphor. This is what happened here. Approximately 4.5 billion years ago, 4.6 billion, to hold the number gently in mind, a nebula in an unremarkable region of an unremarkable galaxy began to collapse. Scientists believe that one or more supernovae nearby may have helped trigger that collapse, may have sent the shockwave that started everything. So the very event that killed some ancient, nameless stars may have been the first cause of everything that would eventually become our solar system, our world, the morning light you will wake to, the face you will see in the mirror. Every atom of calcium in your bones was forged inside a star. Every atom of iron moving through your blood right now, the iron that carries oxygen from your lungs to your brain, that keeps you warm, that keeps you here. That iron was made in a stellar core and scattered across space in a supernova explosion before our sun even existed. The oxygen you breathe, the carbon that forms the backbone of every molecule of life in your body, the nitrogen, the phosphorus, the sulfur, all of it, came from stars that lived and burned and died long before our world was even a thought in the mind of gravity. Carl Sagan said it, and he said it because it is true. With a truth so deep it quietly rearranges something inside you. When you really let it land, we are made of star stuff. Not poetically, not approximately, literally, the stuff of ancient stars, expelled in their dying, mixed and drifted and collapsed again, and through a process so patient and so intricate that it humbles every human word for patience or intricacy, it eventually became you, your thoughts, your dreams, the warmth of your body under your blanket right now. Star stuff, breathing and wondering and resting. And here's the thing about this cycle that is perhaps the most beautiful, the most quietly staggering. It does not diminish with repetition. Each time stellar matter is cycled through a new star and expelled again, the universe grows slightly richer, slightly more complex. Each generation of stars, each death and dispersal, adds more heavy elements to the interstellar medium, gradually enriching the raw material available to the next generation. The first stars were almost pure hydrogen and helium. They could not have made a rocky planet. They could not have made water. Life, as we know it, would have been chemically impossible in that early universe. But those first stars died and enriched the cosmos, and the second generation was richer, and the third richer still, and somewhere along that slow ascent of complexity, the universe crossed a threshold where life became possible, where carbon-based chemistry could begin its own extraordinary journey from simple molecules to something that could look back at the stars and wonder where it came from. We are, in a very real sense, what the universe has been building toward. Not in any grand teleological sense, not because there was a plan, not because we are the point, but because we are the current expression of an accumulating complexity that has been building for 13.8 billion years, one stellar generation at a time. We are what happens when stars are patient enough, and numerous enough, and generous enough in their dying. And the cycle has not stopped. Right now, in the Orion Nebula, which you can find with your naked eye on a clear winter night as a faint smudge below Orion's belt, stars are being born from the remnants of older stars. Right now, somewhere in this galaxy, a massive star is in the final stages of its life, building up that fatal iron core, hours or centuries away from the collapse that will scatter its substance across light years of space. Right now, the material from supernovae that exploded thousands of years ago is still traveling outward, mixing with other clouds, seeding the next generation of suns and worlds. The cycle does not pause. It does not rest. It is happening in all directions simultaneously, at a scale so vast that the human mind can only touch the edge of it, like pressing one finger gently against something enormous and warm. You are not separate from this. That is the thing to carry with you, not as a thought, but as a feeling, into sleep. You are not a passenger watching the universe happen from somewhere outside it. You are the universe happening, the atoms in your hands, in your breath, in the slow and steady rhythm of your heartbeat right now, have been through this cycle before. They have been compressed in stellar cores. They have been flung across space. They have drifted in the cold dark between stars. They have fallen into new suns, been expelled again, traveled again, until at last, through a chain of events so improbable and so magnificent that the numbers strain comprehension, they arrived here, in this configuration, in this moment, forming the thing that is you. Reading these words, feeling the weight of your own body against something soft and still. There is something in this that goes beyond comfort, though it is deeply comforting. Something that goes beyond wonder, though it fills with wonder every quiet space it touches. It is more like recognition, like remembering something you never consciously knew. Because when you learn that you are made of material forged in stars, something in you does not say that is surprising. Something in you says, quietly, yes, of course. That makes sense. As though some part of you already knew, as though the atoms themselves remember where they came from and are never quite done carrying that memory forward. The universe is very old and very large and very patient. It has been cycling matter through stars for billions of years, slowly building the conditions for complexity, slowly enriching itself with every death and every birth, never wasting anything, never throwing anything away, only transforming, only passing forward. And out of all of that, out of all that ancient burning and dying and drifting and collapsing, it made, among countless other things, this moment, a quiet room, a body at rest, a mind letting go of the day, softening at the edges, beginning the long, gentle fall towards sleep. It made the darkness behind your closed eyes, and the warmth in your chest, and the slow tide of your breathing, and the last soft thoughts moving through you like light through deep water, growing dimmer and more beautiful as they go. You are ancient. You are new. You are the universe resting in one of its own hands, and somewhere above you, through the ceiling, through the atmosphere, through all that dark and radiant space, the stars are still doing what they have always done, burning, building, giving, and the cycle goes on, and you are part of it. And it is enough, and it is more than enough, and it is a very good thing to fall asleep knowing. And so our star completes its journey, born from dust and breathing light across 1 billion quiet years before returning gently to the cosmos it came from. Just like that distant glow, you too have traveled far today. Let your eyes grow heavy now. When you're ready, another chapter waits peacefully ahead. But for now, simply rest. Good night, dear one. You are safe, you are still, and the stars are watching over you.